Welcome back. My name is Hillary Weinberg. I'm your host of The Whole Gamut. I have here today Professor Saifur Rahman. He is the, I have to look at my paper to read this. He is the Joseph R. Loring Professor of Electrical and Computer Engineering at Virginia Tech, and he is the founding director of Advanced Research Institute at Virginia Tech. It's a mouthful, and that's only part of his qualifications, but this is what we're going to talk about today. Welcome to the show, Professor.
Thank you very much. Nice to be here.
So we're really excited to have you here, and we're going to talk about a couple different things. But first, start off, and talk about your background. I mean, where did you get your education, and what brought you to Virginia Tech?
Okay, well, my first degree, BS degree, is from Bangladesh, in electrical engineering, way back. Came to New York State, Long Island, master's degree from New York State University in electrical sciences. Then I came to Virginia Tech for my PhD in electrical engineering, left Virginia Tech, went to teach at Texas A&M University, and then came back to Virginia Tech some years later. I have been working on solar energy since 1981, and I was asked to teach a class on solar energy, and I was doing work for a power company in North Carolina who was looking at solar energy and wind energy to replace nuclear power, which they had to cancel because of financial reasons.
So did they end up implementing that? Or?
They did some, yeah. But it was very expensive at the time, almost 35 years ago now. But North Carolina now is fairly strong in solar in the country. They're like number 5 or 6 in the U.S.
I didn't know that.
Yes, yeah, they're very good. So solar is good in of course, California. The biggest growth now in the U.S. in solar is in Massachusetts, New Jersey, and Vermont. Interesting.
Wow, those are pretty cold, cloudy states.
Yes.
That's interesting.
Because of the political awareness, tax incentives, and so on and so forth. On the wind side, number 1 is not California, it's Texas.
Yeah, I believe that.
Yeah, number 2 is Iowa, not anybody else, because of the wind and because of the local tax incentives.
Yeah, wow, that's really interesting. Because we always think of renewable energy as this more liberal thing, but clearly it's popular in states that defy the convention, defy our stereotypes. So that's great. And so you're studying at Virginia Tech. You have this fellowship, and you've had it for quite a while, it seems. And what is the Advanced Research Institute?
Yeah, this institute was established almost 15 years ago now to provide high-tech consulting and education services in the Washington, D.C. area for Virginia Tech. So we do work on renewable energy, energy efficiency, smart grid, transportation, big data. Then we work in the area of how to integrate solar energy more efficiently into the grid. We also do a lot of work in other countries like China. I do a lot of in China, India, Bangladesh, Middle East, North Africa. And we also give training to engineers and policymakers from many developing countries in the area of renewables and how renewables can help to minimize carbon emission and help to mitigate global warming challenges. Those are the big areas we work in.
Wow, that's a huge commitment for what you're running. It must be huge. You must have, how many projects do you have under you?
Right now, about 7, 8 projects. One big project, and we don't think that to be the case, California, Texas have some very good wind resource, but offshore Virginia has one of the best resources in the world, offshore Virginia. So we have a DOE, U.S. Department of Energy contract to build 2 6-megawatt each offshore wind turbines 40 kilometers from the Virginia shore.
Wow, that's so interesting.
It is.
Yeah.
We don't realize we have so much strong wind in the ocean off Virginia. That's a big deal for us.
And is there a lot of pushback from the local communities, or are they happy to have
this is the thing. Virginia, on the land side, wind is not that strong. But the bigger problem is public in Virginia do not like to see wind turbines.
I never understood that, because wouldn't you rather see a wind turbine than see a nuclear power plant or a coal power plant? I mean, have you ever been anywhere where there's a coal power plant? It's disgusting. In the air.
The point is, you can build one coal power plant to give you 2,000 megawatts. You have to build 500 wind turbines to get 2,000 megawatts. They're spread out all over the place. So we said, fine, if you don't like wind, you don't have to see it. So if you go back, if you think about this in physics, if you go out 40 kilometers or 26 miles into the ocean, because of the Earth's curvature, you don't see it from the land side. So that's what it is. Give me 1 second.
Okay, no problem. I see. Professor's in an energy efficient building right now.
If I don't move, the light goes off.
Right.
So that's why we chose to go 40 kilometers out, so that nobody will be able to see it, but we'll get energy anyway and bring the energy back to the ground, to the shore.
Wow. So there's so many things to talk about here. I'm really excited about all of them. But I thought we should start. Let's start at the, you've worked all over the world, at the 100,000-foot level, and you're working on domestic projects and state level projects, the 10,000-foot level. Let's start at the 1,000-foot level with some of your work on smart buildings. And I really like the way you described it. You said, making buildings smart and keeping building occupants comfortable.
Right.
So,
let me give some. Go ahead.
So go on. Give an example, or how did you get to that topic?
Yeah, why we were asked to do this. In the U.S., there are 13 million buildings which are like office buildings, commercial buildings, 13 million. Out of that, 90% do not have any kind of energy efficiency devices, controllers, because they are very expensive. So we were asked by the U.S. Department of Energy to review that situation, build some software which will work with existing hardware in the buildings, and we will look at the building occupants' behavior when they want heat, when they want the cool temperature, when they want more ventilation, and learn from those building occupants' behavior, so to speak, and design the software so that it will mimic what the building occupants are doing and thinking, but at the same time, control their temperature, set points, control the lighting level, control some other loads so that they don't know I'm controlling it, but I'm saving electricity.
Okay, go on.
For example, if I go to your studio and turn the lights down from 100% to 80%, most likely you're gonna tell the difference. I can save that much electricity. So we have done those experiments in my lab right here in this building. And we've shown to people from different schools, offices, then factories, that you can do this remotely without causing the occupants any discomfort. That's number one. Number two, there are programs in the US where, like on the East Coast, on a very hot summer afternoon, the power company, with your permission, will turn your AC off for up to 2 hours to save electricity, so they don't have to turn on expensive generation. But in those 2 hours, temperature goes up by another 5 to 8 degrees Fahrenheit. That's uncomfortable.
Right.
This is the difference between what has been proposed before and our approach. Our approach is, we will do the control, we'll save you the electricity, but we will not cause you discomfort. So if the temperature goes more than 2 degrees plus, we will turn the AC back on and do something else.
This is really great, because I think a huge problem with the climate change or environmental movement, whatever you want to call it, is we don't really focus on, like, yes, if everyone went and lived in huts and hunted and gathered, yeah, we'd use less carbon and we'd use less electricity, and clearly, but your average person's not going to do that, and they're just focused on their day-to-day. And your average person wants to be comfortable. I mean, the reason we have air conditioning and heating is because you want to be comfortable and you want to be able to live your life. And I'm a firm believer that you can have these technologies or situations without interrupting life. And this is a great example of that. I mean, these types of technologies really move renewable energy and smart grids and smart buildings and all of this stuff from the far left to somewhere in the middle. Mainstream. Make it, so, how Whole Foods is, it's like the Whole Foods of building technologies where it used to be hippy-dippy, but now everyone goes, no matter where they are, because they made it beautiful and fun and enjoyable and
then affordable too.
And affordable. Well, Whole Foods in Hawaii, it's not very affordable. But that's great. So how do these technologies affect the bottom line?
Right. So number one, we save in two different ways. If you look at the electrical power supply in a building, it has two components. One is the capacity, how much power you're pulling, how many kilowatts. Second is how much energy you're using over the 24-hour day or 1 week or 1 month. So we look at both because you have to save energy to save money. Mm-hmm. For domestic customers, we are billed based on total energy consumption per month, domestic customers in this country. However, for the commercial customers, industrial customers are billed in two different ways. One for energy usage and what was their highest power demand over a 15-minute period during the day. So that's a very high charge which we don't pay as domestic users. Or the commercial buildings pay that charge. So as we come to the peak period, typically on the East Coast, summer afternoon, between 3 to 5 p.m. is the peak load because of the air conditioning demand. So during that time, power is very expensive for the commercial building operators. So we are saying we will control your fan, light, air conditioner, whatever is possible, so that you reduce your peak power demand and at the same time save energy. So the bigger saving is the peak reduction, more than energy savings, but our technology works 24/7 throughout the whole year. So we look at when there is opportunity to save, turn things down, not off, so that we can save some energy for you as well.
Okay. Wow, that's great. So all these technologies, so you said the Department of Energy is funding this research. Do you know why they chose to fund this research project?
Well, what they tell me is there is a significant opportunity to save energy by making people aware of why they're using so much energy. Many people know that, but there has not been a low-cost, affordable solution to apply energy conservation technologies in commercial buildings without causing discomfort. If you go to a large building, which is 5, 10-story building, those buildings are big enough, they can afford to spend $1 million to do the energy savings applications. The smaller buildings, doctor's offices, grocery stores cannot do that. So our focus has been to look at those smaller buildings and do some smart software solutions so that the building owners, building users can save energy.
That's great. At this point, we're going to cut to a break. We'll be right back, and we'll talk more about smart buildings and smart grids. See you soon.
Okay, very good. Thank you.
Hi, Jay.
Hi, Keith.
My name's Keith Bettinger.
I knew that.
And I'm the host of ThinkTech Asia.
I knew that too.
Here on ThinkTech.
Fabulous. You got a great show going, Keith.
Thank you very much. And for our viewers out there that are interested in ThinkTech Asia, it airs every Tuesday from 4 to 4:45. And it can be accessed online at thinktech.com. ThinkTech.com.
Yeah, so what kind of guests you like?
Well, we have a number of guests from academia, from practitioners of international affairs. Sometimes we have military officials. Sometimes we have public officials on the show. And our goal, we try to talk about current issues in South Asia, Southeast Asia, East Asia, and Central Asia, all throughout the Asian realm in more depth than you would find in traditional mainstream
That's the
media.
difference, isn't it?
Exactly.
That you're reaching out beyond what ordinary news media would do.
Right.
That's why we like you so much.
We're trying to provide a thinking person's perspective, an intelligent perspective on what's going on, and we're both sides of the story, or even when there's more than two sides, we try to cover every angle. And I think that's one of the big benefits that we provide here at ThinkTech. Is it's a really innovative source of educational programming for the people of Hawaii.
You're great, Keith. You are a great host. You got a great show going on. I watch it every week.
Thanks very much.
Why don't
Jay.
you guys watch it every week too, okay?
4:45 to 4 to 4:45 every Tuesday.
Aloha, I'm Kirsten Baumgart-Turner, and I host Sustainable Hawaii every Tuesday from 11 a.m. to 12 noon. My guests offer insights on challenging economic and environmental issues facing our state and offer innovative solutions to increasing Hawaii's long-term sustainability. Recently, we've been focusing on sustainable land development, food, and energy security. If you have a project or issue you'd like to discuss on the show or would like to be a guest, please contact me at kirstenbturner@gmail.com and tune in live weekly or view the show at your convenience at thinktechhawaii.com. Mahalo.
Welcome back. I'm your host, Hillary Weinberg, and this is The Whole Gamut. I'm here with Professor Saifur Rahman at Virginia Tech, and he is here talking to us about smart grids and smart buildings. Welcome back to the show, Professor.
Thank you very much.
So we were talking, before the break, we talked about smart buildings, these new technologies you're helping develop, or software you're helping develop to make buildings comfortable for people, but also make them energy efficient. So we're talking about the, just in general, so how does this affect the commercial industry, and how is this different with commercial buildings versus residential buildings or smaller ones?
If you look at my first slide, which talks about commercial building sizes, you'll see the blue line, the blue bar. Almost 50% of commercial buildings in the US are fairly small, meaning from 1,000 to 5,000 square feet. There are homes that I have seen in Virginia which are bigger than these. So these are small buildings, half the buildings. Remaining 40% or so are below 50,000 square feet. So if you take all the buildings in this country, ranging from 1,000 to 50,000 square feet, that's 90% of all buildings in this country. And these are the buildings, because they're small, because they are not that smart, I guess, they do not have much opportunity to reduce electrical energy consumption. So we are targeting those buildings in our research so that we can make a huge difference by giving low-cost technology, mainly software, so they can control their buildings better.
Oh, it's Pareto's, is it Pareto's law that, 80% and 20%. So 20% or less of the buildings are producing 80% or more of the electricity.
Right. And because they are small, they are not that expensive to build to begin with. They don't add the extra $500 million or so required to make the building small. That is the target, or that is the market we're addressing. And we are using existing building hardware, your thermostat, your fan controllers, your lighting circuits, but our software can sense what's going on and recommend control by the building operator. And this is done without any intervention, in the sense you, the building operator, don't do anything, just let it work, but you have the full capability to override and turn things back to where you want it.
So that's great. So let's talk about this. What was it, BMOS technology? And this is all under that umbrella.
Right.
Oh.
So BMOS, BEMOSS, stands for Building Energy Management Open Source Software. So that is what we're building, and it is open source because when we are done by the early part of next year, 2016, we will release this software as an open source software. Anybody can take it and customize it for their building and make the building smart. That's the objective. So you don't have to buy anything else, just download it and customize it for the building you are trying to work with.
Is this only for new buildings that you can implement these technologies?
No, it can be for any buildings. So we have deployed this already in old building that we teach classes at Virginia Tech. That building was built in 1947.
Oh.
And we put some thermostats in the building, some controllers. Those are a few $100 devices, and we are now controlling the temperature, airflow, and so on. One very good example, that building has a lot of classrooms, and they are saving a lot of energy because classrooms are more efficient right now.
This is interesting. So I don't even know where to go next. So this, it says on the website for this technology, it offers scalability, robustness, plug and play, open protocol, and it has this whole list of different things. What do you think the most important feature of these technologies is?
Important feature, first of all, open source, so you don't have to pay the money to get it, it's free. Number two, it's plug and play, meaning you can use any vendor's hardware in your building, and our system will recognize it and give you options to control the way you like it. So those are two. It's free, and it is plug and play, meaning you can use it the way you like. And also number three, it is expandable. You can deploy this on one floor of your building, see how it works for you, and if you like it, you can then add other floors to the software base that we will provide to you.
Wow. Okay. This is great. So, we could spend the whole day talking about these technologies, but I'd also like to get back into the 10,000-foot level and talk about the renewable energy work that you're doing. So, where do you want to start? I mean, just renewable energy. So, what's in general the goal of the research?
Let me address two of those which are the commercially deployed now globally. One is wind, second is solar. Let's talk about wind very quickly, then I'll come to Hawaii, show you some pictures, what is happening in Hawaii, your backyard. Globally, wind energy has taken off significantly. If I go back 15 years ago, it was almost non-existent. Today, globally, we have over 300,000 megawatts of wind in operation. That is like 300 nuclear power plants worth of capacity. 300 nuclear plants in wind energy. Out of the top 5 countries, China number 1, US number 2, Germany number 3, Spain number 4, India number 5. Top 5 countries. And they are using wind commercially. It's not subsidy-based, and it is making money in most cases.
So, this is interesting. People always say to me when I say China is at the head of solar and the wind industry, they go, really? Dirty China? Can you talk briefly on how that's possible?
Yes. I go to China often, and I have done a lot of work in China. I have done a lot of projects there. The reason China is focusing so much on wind and solar, now it is solar, as also wind, because China has the bad name globally to be heavily coal, heavy CO2 emitter. They want to use their renewable sources to minimize carbon dioxide pollution.
Okay, cool, that's great. So the technologies in China, so you're saying, you know, they're able to be number one, and they're number one with solar as well, correct?
No, solar is Germany number one.
Germany's number one. So how's cloudy
China
Germany
will be
number?
China, US is number two now, but China is pushing very hard on solar. You may recall when President Obama went to China last year, agreement with President Xi Jinping that China would slowly reduce their coal usage. So by 2030, I think, they'll be going down in CO2 emissions, not going up. So to help that situation, they are pushing very high to get more solar, more wind into the electric power generation mix. So in a couple of years, China will overtake US in solar, but they're right now number 3 in solar. Wind number 1, and China in number 3 in solar, but going very fast with more applications. And as you may know, China has hundreds of factories which make solar panels. So they are the global number 1 supplier for solar panels, Europe, US, and China itself.
You know, again, defying expectations, you know, we have all these stereotypes about different places, but, you know, dirty China or, you know, Republican North Carolina are actually ahead of the game. You know, what do you think is the major contributor? What makes a place the best at these technologies?
Number 1, why is Germany number 1 in solar? Germany is not a sunny place like Hawaii.
No, it's so cloudy. Have you ever been there?
That's because beginning about 6 years ago, the German government gave a lot of incentive to put rooftop solar. You go to any German city, like fly into Munich, fly into Frankfurt, you see as you begin to land, most rooftops have solar panels because of government policy and incentive. That's number 1. And number 2, some countries like China wants to minimize coal usage. Germany wants to minimize nuclear power usage. Mm-hmm. So they have to find alternatives. That is why they're have pushed so far very hard on both solar and wind.
All right. On that note, we're going to cut to a quick break. We'll be right back in a few minutes. Please stay tuned. I'm Hillary Weinberg, and I'm here with Professor Saifur Rahman. We'll see you soon.
Aloha, I'm Carlos Juarez, host of Global Connections, and I want to invite you to come join us. We cover a range of global issues. We bring a lot of expert opinion, a lot of issues, whether they're contemporary events happening in the world or maybe looking at things from a more historical perspective. Global issues, very important for us to understand in this globally interconnected world. It's here on Global Connections.
Hi, my name is Cindy Matsuki, and I host the show High Growth with HTDC on ThinkTech Hawaii. This is the show where we talk about all things tech, innovation, entrepreneurship, and manufacturing, because there's so many things going on in Hawaii and more people should know about them. So this is the program that you can come and find out about all the things happening in Hawaii. And this show also airs on Olelo 54 along with ThinkTech Hawaii. And it broadcasts live every other Tuesday at 3 p.m. So don't forget, check out the show Tuesday, 3 p.m. every other week. High Growth with HTDC. Thanks.
Aloha, my name is Josh Green. I'm a senator from the Big Island. I work in the ER there. But on Tuesday afternoons, I get to come and spend 45 minutes to an hour with Jay Fidel and the ThinkTech staff. They're terrific professionals. They help us to bring some of the leading cutting-edge topics here across our state to you. So you can join us at our show on healthcare in Hawaii to talk with leaders from across all the spectrum of health in our state, or you can join us for any other show where we talk about economic development or tourism or some really eclectic programs too. So really, we'd love to see you here on our show. Thanks for joining us and thanks for supporting us.
Welcome back. I'm your host, Hillary Weinberg, and this is The Whole Gamut. I'm here with Professor Saifur Rahman at Virginia Tech University. We're talking about renewable energy in the United States and also smart buildings and smart grids. Welcome back to the show. And right before the break, we were talking about renewable energy in Germany and the cuts that they were making, the laws that Germany put in place and incentives for solar, cloudy Germany, to cut their nuclear use. However, I read that they ended up importing a lot of electricity from France, which is mainly nuclear powered. Thoughts?
Well, as you can tell, the sun doesn't shine. Solar doesn't do any good, right? Number one. Number two, if the wind is slowing down, you don't get much power from the wind turbines. So yes, when the sunshine is low or no sunshine, very cold, snowy day, you have heavy demand because of heating load and lighting load. You need power from somewhere. So then you buy power from French nuclear power plants because they have excess power. On the other hand, I was in Germany this summer, and also in near Zurich, Switzerland. And Germany during daytime, have a sunny day, have so much solar power, more than they can use. Then they sell it, or they dump it on the Swiss.
Oh, okay.
So that happens. This works both ways.
Okay, so it's not a perfect system, and then that starts getting into smart grids and storage and how do you manage the power systems. But we don't have time to talk about all of that today, so we'll bring the conversation back. Talking about these different technologies, different ways to have energy in the United States, or to have energy. What is the status of the United States right now?
Yeah. So if you go to my second slide, it says electricity usage in buildings. Many people do not realize in the US, buildings account for 40% of total energy usage, including transportation.
Oh.
So all the energy is in this country, 40% is in buildings, 40%. A huge number. And if you look at electrical energy only, 70% of all electricity in this country goes to buildings, not factories or your homes. Buildings meaning commercial buildings. So that is why we have focused on commercial buildings to make them smart, make them more energy efficient. If you then dig deeper into the building usage, HVAC, the blue part, stands for heating, ventilation, and air conditioning. 30% is in heating and cooling. And more than that, 38%, the red part, is lighting load. We don't realize so much power goes to light up the buildings internally.
Yeah, so go on.
And others, elevators, fans, cleaning, all the other 26%.
Yeah, so is this a significant amount compared to other countries? Because I know China, transportation is the largest use of energy, and the construction industry, steel industry, those are the largest uses of energy, not just general commercial buildings. Then in a lot of Europe, because the United States has very large differences in temperature. In Europe, they may use a lot of heating, but they very rarely use air conditioning. And I'm not sure which, maybe you can enlighten us on which, air conditioning versus heating uses more energy. But does the United States, is it unique in this problem?
Well, if you go to large U.S. cities like LA, New York, Chicago, Miami, at night, most office buildings are lit up and not dark. So we use energy 7 days a week, 24 hours a day for lighting. That's what's so high. In most other countries, lighting load is not so high, unlike US. That's number one. Number two, the lighting technology in the US is pretty old. We have not gone into LED lights and CFL like most other big cities in other countries have gone to. That's the second reason. The third reason is, yes, we like air conditioning more than other countries. Like, on the East Coast, New York, LA, and also DC and all that, we keep our buildings pretty cool in summertime too. So you can wear a jacket in the office.
Yeah. When I worked in DC, I would bring a sweater to the office Sweater
That's
and
right.
stockings to the office, and you take them off before you get on the metro.
Right, that's the thing. That is why the load is so high, unlike, as you said, Europe and other Asian countries. Just to give you some comparison, I used to work in Japan. I was an engineer in Tokyo Electric Power Company some years ago. In the US, average annual consumption of electric energy is 1,000 kilowatt hour average per month on the US side. In Japan, that's 700. That shows that, yes, you can do, and Japan is not a developing country. They have same lifestyle, same buildings and all that, but because of lighting load and air conditioning load not widely used, the consumption is lower in Japan compared to US.
So we're dealing with a unique problem that is mainly an American problem. And so what are some of the solutions?
Right, that's the thing. If you have a bigger problem, you have bigger opportunity to save more. If you waste more, you can save more. So the technique we are talking about here is very useful to US more than Japan, for example, because there's not much fat to cut. There's a lot of fat to cut here. So our technology, BMOS, can be very useful because we have a lot of savings that we are not paying attention to that can be achieved fairly easily.
Okay, so the United States, where are we on the problem? What's the highest energy use in Hawaii?
Hawaii is, because of low air conditioning use, is much less. I don't have the numbers with me, but also electricity is much more expensive in Hawaii, more than twice the rate on the mainland. So people are more careful, and as a result, they're more aware of the new technology like LED lighting that is helpful for the lighting load to be less than average U.S. mainland lighting load.
Yeah, I mean, we're all us in Hawaii, we're very intimately familiar with our electric bills. Back on the East Coast, you'd have a $60 or $70 electric and internet and water bill. And here it's $200 plus, no matter how small your household. So the cost of living is very high, but that's why these technologies are so important. So you have been doing projects on Hawaii, the Hawaiian Islands. Can you discuss them a little bit?
Yeah, let me bring up my slide number 3, which is solar electricity in Hawaii. It's a sample. There are many of these all over the island. And because in Hawaii, electricity is so much more expensive because you're mainly oil-based, and all imported oil. So it gives Hawaii an opportunity to replace oil-fired generation using solar power. So the picture you see here is a set of solar panels, ground mounted, which would be seen if you walk around, drive around Hawaii, that is getting a lot of attention. Let me just go back one more time to a similar situation in a different country. Saudi Arabia, I was there a couple of years ago. The main oil company, Saudi Aramco, they are pushing really hard to put solar in Saudi Arabia, where oil is so much cheaper. And why do this? They say, we have to sell oil to power company at a fairly low price because of government rules. But if we can replace electricity using solar, we can save that oil and sell to America for 10 times the money that we can make.
Yeah, actually some of the Gulf countries are doing some really amazing things with clean technologies and renewable energy because they see this opportunity. They went from a nomadic society to, they have, the tallest skyscraper, they have, these amazing cities, people from all over the world come there for jobs and work, and they're building, and they know that oil isn't the future. So this is why when a lot of times environmentalists, go really against the oil companies in these countries, it's like, well, they see the future. They know very well that oil is not it. And they're building these clean cities, they're building these cities with these research facilities. So there is opportunity in something like this.
There is. So let me go to the next slide, which is on wind in Hawaii. And again, Hawaii, as you know, very well know, has trade winds, and that's throughout most of the year. And this is another source of power, which if we do more of these, hopefully, I know for a fact, the wind electricity in Hawaii is much cheaper than power you produce from oil, using oil, much cheaper. But you need space, you need awareness. The problem with wind and solar, as you can tell, they are not there 24 hours a day, 7 days a week. This is where our research comes in. As the wind slows down, as the sun is going behind clouds, what do? That's where smart grid comes in. We have done research where as the sunshine becomes weaker, the wind slows down, what can we do to keep the system running without interruption? And that's where smart grid comes in. Smart grid will sense, will predict wind is slowing down the next 5 minutes. And it'll do two things. It'll start the batteries backing up the power supply, and it will control the load in your building, in your factory, in your schools, in your offices. How do you control the load? You play with the lighting level. As long as you, the user in the office, cannot tell the difference, if I control the light, then you don't care. So as the wind slows down, we predict it, play with the lighting network, so we can reduce the load, so that if I have lower supply, load is lower, and system is still balanced.
So what's the state of these smart grids in Hawaii, these systems in Hawaii?
This started, there are several electric power company, Hiko Power Electric Company, is doing some projects with U.S. government funding, in fact, and some national labs on the mainland are helping them to set things up. The problem is managing the performance of the solar panels and wind turbines as the weather changes. That's the challenge. If you have a rooftop unit, your own home, some battery, you're okay. But as soon as you begin to supply power to the grid, then people's expectations go way up. They don't tolerate any blackout, any brownout, any voltage fluctuations. That's where the smart grid comes in. It'll take some time, but it is being worked on very heavily right now.
What's your projection? How long do you think it will be before Hawaii has more than 50% renewable energy?
I'm looking at 2020 timeframe.
Wow, okay. You're very
But-
optimistic.
Yeah,
This is
optimistic, provided the current pace stays.
Right.
Now, coming 2016, new election, new president, 2017, things may change. We do not know.
Yeah, and I mean, as well, you're looking at, these are all the island, every island is so different. I mean, maybe Oahu I think that's very optimistic for Oahu, 2020. But maybe, I mean, I'd be very happy, and I think most residents of Hawaii are. I mean, the governor recently said we will not create natural gas infrastructure on the island. So we'll have to see what happens. But unfortunately, we are wrapping up our show. We're in the last minute. Wanted to thank the professor so much for coming on. This was a great discussion. I'm really glad to have you here. Stay tuned for more episodes on energy. We're trying to have someone at least once a month come in and talk about energy in the world. In 2 weeks, we'll have someone from Brussels actually coming on the show. So actually next week, so soon, next week. So great, thanks so much, and thank you, Professor.
Thank you very much, enjoyed it.
Have a great day.